Namaste, Mr. Bossert here. We're talking about areas of shapes. So different formulas that you know, um, ones that you should. Again, I'm not an advocate necessarily of memorizing formulas. Some of you will do that anyway, but I want us to be able to think and reason logically, think them through. So all of the formulas start with the area of a rectangle. Area of rectangle we know is, um, we've got a base and a height, right? And in a rectangle, sometimes we call those length and width. Alright, and we can call them length and width because the sides form a right angle. So length and width, base and height always form a right angle, and since the base and height are sides, we can call them the length and width to find, area. And we just multiply those together. We understand this. Pretty basic concept of multiplying two things together to find area. We're going to if smooth this chapter, so we would say A equals base times height. We'd say A equals, and then we'd fill in. And we understand that it doesn't really particularly matter which one we want to do. Is the base and which is the height, because they form a right angle, so they both depend on how you look at it. And then use my friend the calculator. 48 and 6 is 54. I think that's right. And now it's an area, so this would be, they don't give us the units, so we're just going to say square units or units to the second power. Now the squared are the units to the second power. The 54 is not squared, right? The 54 is how many square units there are, and there are 54 of them. If we, did the whole thing, 12 here and 4.5 here, you'd have 54 of those squares, or square units. Alright, parallelogram. What's that look like? Well, basically it looks like a rectangle, but if you don't have the sides meet at a right angle, right, like a rectangle, let's say we took part of it and cut it off, and took this piece and slid it over here to this side and then reattached it, it would look like this. That's what a parallelogram is, kind of. Alright, but now the thing that was the base, right, is the same size as this one is on the top, that base. Oopsies. Alright, this is the same size, this base, but it's no longer kind of coming out here. And now the main part here is that the right angle, or the height, right, which is in the middle here, is not one of the sides anymore. So we just have to be careful about that. But the key point is that you do want to make sure that the height and base always form a right angle. So that's kind of, in any of these shapes, that's kind of a key component that we need to understand, is that the height and base form a right angle. Alright, so here the 7.5 doesn't really have anything to do with the area. We're looking at basically 5 times 20 to get an area of 100. If you took this piece over here, cut it off, and slid it back over here, it would reform a complete rectangle. And there would be a 5 by 20 rectangle. It has the same area, so it's 100. A triangle, we understand that if we took a rectangle, right, and we cut the rectangle in half, getting rid of this top part, right, we'd have this triangle. Let's put this in green, maybe that looks fun. Alright, so this triangle right here has the same height as the rectangle did before, has the same base as the rectangle did before, but since we've gotten rid of half of the area, it's half as big. And And so that's the reason that the area formula for a triangle has 1/2 in it. It's because the same size rectangle with same base and same height rectangle, the triangle will have half the area. Right. Now, we'll do some applications of these where you have to find maybe the height or find the base and height. In this one here, we've got a triangle here. The entire base is 6, right, across, but in order to find the height, we need to use this half. We need to use 3 and 7, and look, we've got a right angle, so that's a Pythagorean theorem. So we've got a squared plus b squared equals c squared here, and we've got 3 squared plus, I don't know what base the b is, so I'm going to say that's x squared equals 7 squared, and so x squared is going to equal 49 minus 9, or 40. So x is going to equal plus or minus root 40, which we know we're not going to use the negative 1 here, and then I simplify this to be 2 root 10. So 2 root 10 is now the height, so my area formula is going to be 1/2 base times height. And so 1/2 times 6, where the base is all the way across this triangle, 6 times the height is 2 root 10. If I was doing this, I'd say the commutative property, I multiply 1/2 times 2, and they cancel each other out. So the area is just going to be 6 root 10. And then it's square units. Going back up here, you've got a right triangle that is isosceles right triangle. So this is a 45, 45, 90 right triangle. Think back to our last lesson. And I'm going to pause it, and you see if you can solve this. You got to first figure out, now the base and the height are the same. That's good. And this 6 root 2 is a clue to you. So pause it and then come back. Okay, so I have, excuse me, I have, you probably understood from our 45, 45, 90 that the hypotenuse is x root 2, which means that x, or the legs, had to each be 6. If not, you could do Pythagorean theorem. They're both x, so x squared plus x squared equals 6 root 2 squared. And solve it, you should get 6. But again, if you memorized or remembered from our previous thing that this is x root 2, that meant that each of these x would have been 6. So then if they're both 6, multiply them together, you get 36. Half of that is 18 square units would be the area. Alright, and then a trapezoid. Again, I'm working off the rectangle again. Alright, everything starts with the rectangle, which is base times height. And you'll see the way I write this formula, maybe it looks a little different, but a trapezoid is basically you taking one base. Alright, if you took this piece off and flipped it over here and added it to the bottom, right? So took this, cut it off, and flipped it over and put it on there, right? Your shape would look like this, which is a trapezoid, right? And the trapezoid has the height in the middle, okay? Right, it's not one of the sides, it's in the middle where it used to be when it was a rectangle. And now one of the bases is smaller, one of the bases is larger, but the average of those two would get you back to the rectangle's base. So that's what we do. We find the average base, add them up and divide by 2. Now a lot of times you'll see this formula, 1/2 b1 plus b2 times h. But again, what is this? That's how you find the average of the bases. You add them up and then divide by 2 or multiply by half. But I just want to say, oh, it's the average base times the height, because then again, it looks like the rectangle formula, which is what it came from. Has essentially the same base, but we just have to average them together. Alright, so we take a look at this. The average of the two bases, and the bases are where the two parallel sides would be the bases of a trapezoid. Average of those two bases is 8. 8 times 6 is 48, so the area of that would be 48. Circle we should know is pi r squared, alright? for this one, again, this is a can you fill in the formula. It's going to be even easier than when you were in 4th or 5th grade, because I'm just going to want to leave it as in terms of pi. So 64 pi is a great answer. We don't need to. Now, if they do ask you to round it to the nearest hundredth or whatever, then you can use 3.14. But if not, this is an exact answer. That is a great answer. 64 pi is the area of that circle. And last thing is, if it's just a sector of a circle, all right, like a Pac-Man, all right, we're gonna find, you know, the area of this blue region. Okay, that's sector. Pac-Man's mouth, I guess. It's just a fraction of the circle. So figure how much of the fraction of the circle it is, and times it by pi r squared. You can find the fraction of the circle, whatever the degree measure is, and divide that by 360, so that'll tell you what fraction of the circle it is, and times it by pi r squared. So this is 60 degrees, so that's 1/6 of a circle. So 1/6 times pi times r squared. So this is going to be 1/6 times 100 pi, or we can leave it as 50 pi over 3 square units. Alright, reduce the fraction. If you wanted to make it whatever that is, 16.6 repeating pi square units. If you did this with this weird thing, alright, typically then we're going to use 3.14 and put that in there for pi. And then approximate that. Again, read your directions, whatever it asks you to do, make sure you follow the directions. But if you leave it in terms of pi, that's going to be great. 50 over, notice I didn't have it 100 over 6. 50, I reduced that to 50 over 3. So you want to do that. 50 pi over 3 square units is a great answer. Alright, this will get us started, and we'll explore more of this in class with our problem set. Thank you very much. Namaste.